Good morning. Hi. I should say good night. It's like 11 p.m. here. My name's Tom. I talk about code, and today we're back with more Rust programming. I don't need these headphones. I can't hear anything. These aren't even connected to this computer. Let's ditch the headphones. Back with more Rust programming today. Last stream, unfortunately, had to be cut a little bit short. I was feeling a little bit unwell, so I didn't get to finish off the wonderful macro work I was doing. But let me tell you, if you didn't catch the stream, the macro work is very, very good. My hair is out of control. I really should have put it up or done something other than this with it, but it's fine. It's too late. I'm committed now. I've hit the button. I'm going to paste a link to this stream into my Discord, and then we're going to jump in and start looking at what we did last time. That was the wrong scene. Okay, so if I cargo build right now, I think it's going to yell at me because I literally left things halfway done. Okay, so literally, where are we? We're in code value. Yeah, I was halfway through doing some stuff. There was a dangling match statement, I think. I might have accidentally walked some changes back. That was the wrong thing. Okay, we're just going to quickly grab this link, paste it, and then we are back coding. So last time we implemented automatic instruction encoding in a macro, which is cool. Which is very, very cool. So last time, right? So we don't have to manually write what the encoding for our instructions will be. We can just derive it because all of our instructions, they kind of look like this. They're either, you know, a push which has one unsigned 8-bit number as an argument, something like this which has one register, or something like this that has two registers. And we found a really nice way to represent that matching on a slice, which is cool. A little bit of annoying stuff to convert our vec of string into a vec of stir slice, but that's okay. We can deal with that. And this was just so clean, right? So if our variant has one type. I think this is called like the discriminant, right? Or is it get type fields? Yeah, I think this is like the discriminant or something. I can't exactly remember where is this? Ident x fields. Okay, the fields of the variant. Sorry, maybe I'm using the word discriminant wrong again. I probably am. I used it wrong a lot last stream. So the fields of the variant have types. We look at the names of those types, and then we decide what the decoding looks like, because these types here absolutely determine how the instruction is encoded and decoded. So we've done that for encode. Encode works. I'll try from, where are we? From stir, encode U16. And we just dump this code. So one of the cool things about the quote macro is you can quote things, you can include things you've already quoted. So here we're just generating this directly. We're using this quote macro again. This quote macro is just building an AST of these things, but everywhere there's a hash. It's like a funny little DSL that lets us do special stuff. So we want to do the same thing again. And sorry, this was encoding. We've done this for encoding. We want to do the same thing for decoding. And decoding's like encoding, it's just backwards. So that's cool. So field decoding. So if let's just go, right? So if we're encoding an instruction, right? We encode, say, a push instruction into the push opcode followed by the literal. If we're decoding a push instruction, now hold on, I just need to quickly look at what this actually looks like. What does this look like? Okay, so decode. We look at the opcode. Okay, so the only thing I need to think about is what the left-hand side of this arrow is, right? What are we actually matching on when we're decoding? And I think we're decoding a full use. Well, yeah, we're decoding the opcode, but we want to do the opcode. We want to do the opcode as a value, right? Does that make sense? Makes sense to me. So the identifier. We want to get the opcode value. And this is exactly what I started writing. Variant opcode value. Now, this is not a U8. This pass args unwrap, this is not a U8. Right now, this is something else. This is, well, it's a lit int, right? It's this lit int, and we're going to dive back into our wonderful Rust sin lit int. We're going to dive back into these docs and see how we can get this as a thing. And it looks like there's a base 10 parse function. So let's go base 10 parse dot unwrap, because if these macros are going to fail, they're going to fail loudly and they're going to fail violently, no matter what we do, right? This top level thing, I don't think we can return a result. I don't think that's something we support. We just have to blow up. So there's a lot of unwrap here that I don't love, but we're going to work out how to deal with that later. I probably should, you know, use result types here and kind of push this ugly function signature down out of sight, push all of the unwrap down under the rug, you know, and actually use results. But anyway, it really highlights the importance of having good test cases for all of this mess, because holy crap, when it fails, the compiler does not give us nice messages. Okay. Let's see if this works. So I just need to go let opcode value equals, what is it? What am I doing? So variant opcode value, let's just quickly mark this as B, variant. So this is just, is variant opcode value, and this is our X. So opcode value. So if we're dealing with this opcode, we decode it, right? We decode it. So we get self, we get the instruction. And then we're gonna have some kind of like the variable in this context. So I guess let's maybe start to actually write this, right? So impl instruction encode u16. I should use proper types for this. This is an into u16, and I'm gonna impl try from u16 for instruction. Okay, so try from result self error. Okay, now the opcode is the lower byte of this 16-bit number. So we match on the op, and then we do this wonderful thing, which says just, you know, put all of the things in this list here, and that will be everything we quote here, right? So this is similar, right? So it's called B. Let's maybe call this ins for instruction. Okay, and we're just gonna rely on the fact that this thing is called ins. So we're gonna have ins and 0xFF00 right shifted to the 8, and this whole thing is gonna get downcast to a U8. And that is it, right? So this will match, for example, the opcode of the push instruction, and it will map it into a push instruction with the one unsigned 8-bit integer as its as its argument, maybe, right? As its field, as the field of the variant. And that's the official Rust language. This is going to be the same thing, except it's going to be a register, and these registers are only 4 bits in size. We still right shift it by 8. That's now I definitely just munched a line there. Okay. For example, push. Yeah. So we do this. Oh no, we don't though. There's another step here. Let. Actually, no. Well, here's the thing. This doesn't need to be readable because we're just gonna do it all in this one disgusting. Maybe. So maybe we actually. Well, I guess. Reg. this needs to be wrapped in double quotes, in curly braces, sorry. That's all we need. And quote knows how to deal with this, right? Quote doesn't care what we're quoting. Quote is happy. So this is the instruction, and 0xf00 right shifted by 8. This is the value of the register, right? We have 16 potential registers. And then the actual register value is well, this is the register value. Then the actual register is register from U8 reg U8, and then we just copy our OKR and our map. And, you know, even though it doesn't need to be the most readable, maybe shift over a couple more. We'll do the same with this map. Except now we're going to use self and we're going to use name, which is the name of the current instruction that we're generating an encoding for. Okay, so if we have one register, then this is perfect. Now if we have two registers, it's the same thing, but we just have to do a little bit more work. Okay, so opcode value, opcode value, we just have to do this thing with two registers, and the first register, hold on, we don't actually need to remember, like we're just returning this whole instruction. There's no let needed here. We're just this is just returning out reg1 value, reg2 value. It's the top 4 bits, so we have to right shift over an extra 4 to get it into the bottom, and we no longer map the result, right? We just get the register. Reg1 value. Okay, so we have our two registers. Let's quickly fix this as well while I see it. Cool, we can simplify our naming because we don't actually need to bind anything to a variable here on this side, which is great. And then this is just self name reg1, reg2. Excellent. That's it. That's all we do. That's all we need. So we have the decoding, we have the encoding. So try from instruction, encode 16. Sure, let's go with this for now. Cargo build. Okay, so there's some problems here. Yes, excellent, excellent. Line 22, val. I lost track of what that was. Where is this? Oh, sorry, cannot find X in scope. This one is line 96. Okay, so 22, X becomes V. 96, value, yeah, cool. Okay, now we're getting there, The trait parse is not implemented for U8. That's fine, What am I doing? That's very silly, because if we haven't returned anything, like, you know, here I'm trying to return the value of 0, but I actually just want to return the value of... no, what I want to do here is to panic. Opcode has no value. Or in instruction... no opcode value, and this instruction is associated with the variant v. A variant doesn't implement debug. Of course it doesn't. Of course it doesn't. Variant.toString, maybe, hopefully. Unsatisfied trait bounds. Ooh. But its trait bounds were not satisfied. Okay. Let's just go very simple for now and pretend that it doesn't exist. Unexpected token dot. Okay, this is good. This is good. Cannot find unexpected token dot. So these compiler errors are garbage. Okay. This is awful. This is awful. It's so hard to know what these mean. Error to derive macro. Cannot find value reg1 value in the scope, reg2 value in the scope. Okay, so there's something going wrong where we have reg1 value. That would be because I forgot the word let. Doesn't that make a lot of sense? Yes. Yes, it does. Now this is try from implementation, which we're gonna just put in the bin. Just gonna put it in the bin. There we go. It's all gone. Everything except for just the most raw definition of what these instructions look like is gone. And I love it. That makes me so happy. At M, I have 2 dots on line 101. Oh, I have 2 dots. I've got 2 dots. Thank you so much. That's amazing. Keen eyes. I love it. I love when I watch a programming live streamer and I can see the syntax error that they're failing to notice, and I'm just like screaming at them. I've made the same mistake again, right? Here. Literally. Insanity. Okay, this is good. This is good. I expected U16 found instruction. The instruction has type U16. Cool. Okay. We'll deal with that phone notification in a minute. Nop, unit variant defined here. Introduce a new binding instead. Nop is interpreted as the unit variant, not a new binding. Ooh. See, yeah, this is when I need this. This is when I need this. Oh, wait. I know what this is. I know what this is. I think this is the problem. I think. Bobbius, welcome. Welcome. You're just in time for compiler hell. Expected U8 found instruction. This expression has type U8. Nop is interpreted as a unit variant, not a new binding. Nop is interpreted as a unit variant, not a new binding. This makes me feel... I really want to see the output of this. Wait, so let me just see, right? Because this is saying in nightly, I can do this. Can I just try this? I don't think I have nightly, but let's see. This is the stable channel. Okay, so I could try swapping to cargo nightly. Or I just read this message a little bit more carefully. Expected U8 found instruction. See, oh, okay, hold on. Here's another thought. Try from. So this is that decoder. This is good, but this needs to be okay. Oh, wait. I've got a thought. So this is okay. This is important. But here, what are we doing, right? So we changed what our decode looks like here, but we forgot there's this early out condition. So this actually is opcode value. So we have an early out for if, because we can't match there are 2 different types of fields. One is unit that has no types. For example, a nop instruction. And this is why we're seeing nop instruction as the primary culprit. Why it's an error. Something about a nop instruction. I couldn't understand it. But here we go. So it's self name. Right? We don't have anything to decode. We just match the opcode value and we map it into a thingamabob. This is good. And now we just need to wrap it in OK. And now it's going to work. Now it's very, very close to working. Expected register found result register string. Okay. Okay, okay. We can do with this. We can do this. Expected register. So what expects a register? This expects a register? Ah, and that would be it. That would literally be it. And this is gonna work. We're so close. We're so close. Oh, and then again, this is a real, like, this error. My God, look at this error. This is disgusting. But what all it wants us to say is unknown opcode. All it needs is us to provide a default error case. Conversion method toString. Conversion method toString. ToString. Type constructing contains a static stir. Oh. We need to actually format the string. That's important. Not nearly as bad as C++ template errors. I can't even imagine being a C++ developer. It just sounds like such a freaking nightmare. Prog.bin. All right, let's see what happens when we run our program. Okay, now. That's different. That's not the answer we expect. Interesting. Interesting. That's very, very interesting. Okay. I've got a thought. But also maybe not. We're gonna implement another macro. Okay, we're gonna implement yet another. Okay, so basically, right now, this all this opcode stuff, this is running on borrowed time, right? This stuff is probably all going in the bin very, very soon, but we're not quite there yet. Let's do impl. I can't quite remember what this function signature looks like. Frust. We're gonna make instructions printable. Actually, wait. Or do I just want toString? Bobbius says macros, the problem and solution to all of life's problems. Yeah, you know, writing Lisp, right? You spend more time debugging your cool macro code than actually like solving problems. But that's cool. It feels good to do. Okay, we're gonna import toString. I don't think I need to like import something for this, right? But I guess we'll find out pretty soon. Fn toString. Okay, and now we are gonna match. We're gonna match self. And we're gonna say it's gonna be the opposite, right? It's gonna be the opposite of what we did up here. Field names. It's okay, yeah, so it's the opposite, but we're gonna have to build it like this again. Really? Really? Yeah. Yeah, really, unfortunately, because we need to know what's in it. Well, okay, we don't need to know what's in it right now. We can just say, no, we do though, because we can't match. You can't just, for example, match pop register. You can't match this without the actual register, right? So to even build the syntax trees, we need to know what the types are. So we're going to copy paste this again, which I hate, but it gets the job done. And this is kind of important. We're going to need this to go both ways. So field to string, I guess. We'll go to string. Cool. So name And now toString doesn't fail either, so this is just going to be stringify name. Let's go B for byte. So we capture whatever literal we have coming along with this instruction, and we're gonna say maybe format. Cool. And this is going to be the same thing again, name with the register. God, this is much simpler at least. I think this is how we do this, right? Because otherwise we have to like dereference the thing. Someone pointed this out last stream, and it was very helpful. Panic. Excellent. Excellent. Okay. What did I call this? What did I call this? I called these field toString. Field toString. And this is a total match. Like, we don't have to worry about a default case here. Okay, now opcode value. Yep, cool. Two things that I have done that are silly. The first is that I've still got the opcode value, even though this is unnecessary. The second is these need to be prefixed by self, because they're enum variants, and the Rust compiler just needs us to be really, really clear about what space we're operating in. Okay. I think this was silly. I don't think that's how we actually do it. I think I did something wrong there. String found stir, yes. Now this is good because we get a stir. Actually, wait, no, hold on. That's not right. Because these are actually strings. I was thinking I was going to return just fixed strings, but it's actually kind of the opposite. ToString, I think. Yeah, that's better. Now we don't have a toString implementation for register apparently, so that's silly. Do I want toString, or do I want to implement display, which is Oh, okay, no. Well, so if I'd have Googled this first, I would have found that there was a wrong answer, a right answer. But it's good. It's good to have a very printable way of rendering things into a string. Okay, so standard format display. The function has the signature fmt, which takes a reference to ourself, and it takes a mute. It takes a formatter with a lifetime that we don't care about, and it's going to give us back a format result. That's fine. Okay, now we write to this formatter. What we're going to write to this formatter is going to depend on what we are. If we're register A, then we just write A, B, C, M, SP, PC, BP flags. M, SP BP PC. That, of course, who could forget our boy PC, and flags. Excellent. So now we can turn registers into strings. We're gonna come down, we're gonna change this into a impl display f, which is a formatter oh, and write returns a format result, which is perfect. Okay, a mutable reference to a formatter. Then this, yeah, as I said before, fmt result. And so now we just need to say, again, this is actually quite simple to do. We just say write f this. Extremely simple change. We just need to prepend everything with this variable and write, write I don't think this is redundant because this is a actually no, that is redundant. Because it's a stir slice, I'm pretty sure. Okay, so we now, of course, need to use, what is it? std. And then we also need to do this here. I don't know what the deal is with imports. Like this depends on this. That's a little bit messy. I don't know how this works. Okay, apparently, yep, we forgot an exclamation mark on write. Okay, we're really close. Cannot find trait display in the scope. Register. Oh. That is very silly. Because this is format display. This similarly is format display. Okay, now it works again. Now we can cargo run and see that we get the wrong result. So why did I just implement display? I implemented display because now we're just gonna go in and do a really silly thing. And every instruction that we run, we're just gonna say println, we're just gonna print the instruction. And now when we cargo run, oh look, I mean this is quite beautiful, right? This is a thing of beauty. So we push one, we add the stack, pop register. So okay. As you can see, our register, and if I'd have actually read this more carefully, I would have noticed this is not correct. So for one thing, we shouldn't be pushing one. This is wrong. For another thing, yeah, the register. So our whole instruction encoding is a little bit broken. The now the opcodes, beautiful. Okay, absolutely beautiful. These are all correct, but everything else looks a little bit dud, except for seemingly the signal number. FO. Yeah, okay, that's very weird, right? Because if all of this is wrong, then why is the signal number so good? Okay, so let's double check what our instruction encoding looks like, okay? Let's just focus in on the unsigned 8-bit number. So we have a 16-bit instruction. We've masked out the bottom byte. Okay, so here's the obvious thing to me. right, is that I never know which order these things get applied in, but I have not been overprotective with my brackets, and that can sometimes cause issues when you're doing this kind of mask and shift. So let's just be very protective, okay? And now we get the correct answer. So it was literally that simple. It was literally that simple. Let's commit everything here, even though we've made multiple changes. Let's say macro implement encode and decode print instruction. I'm just trying to keep my column width appropriate for a git commit message. Okay, excellent, excellent. So our encoding and decoding is done. That's it. We never have to worry about how instructions are encoded and decoded again, hopefully. Now, there is one thing that still really bothers me though, and that is the existence of the opcode type, right? Because before, when we were writing this by hand, it made a lot of sense when we were decoding to extract the opcode and then match against the opcode, but now we can just match against a magic number, right? Because it's a macro, because we're generating this automatically, it doesn't matter if we have hex 10, if we have 15, if we have 125 on the left-hand side of this match statement, because we're generating it by a machine. The computer isn't going to make a mistake. It isn't going to type 123 when it means 122. So the whole value of this opcode type has kind of started to disappear. Okay, so we've just committed everything. We're in a clean branch. I'm going to delete opcode. Opcode is going in the bin. Okay, there, it's gone. And Tom, you're saying, you're crazy, you're out of control. How are we gonna live without opcode? Well, look, opcode, okay, opcode was being, wait. Okay, so opcode was being used here, but we don't actually need it, right? We don't actually need, all we're using it for here is the value. Right? We're just using this to get the numeric value. So let's grab the opcode value like we are in the other place, and then put, just dump it in line here. Now, we won't even need to cast this. It should just get cast automatically. Here, we are gonna cast it explicitly. Right, because here it's just a numeric token. It doesn't actually have a size, I don't believe, in the AST. Okay, so that's one place it gets used. Yeah, let me pop out my chat, right? Because we've got Bobbius pouring one out for opcode. Served well. It was a good stepping stone before I decided I was going to do everything as a macro. It served its role. It served its purpose. Okay. Fromster is unused. Let's clean that up real quick. Okay, now. Field names is now unused. Interesting. Field values would also be unused. That's very interesting. That's very interesting. Expected U16 found U8. It's odd that we should get that error right as I was touching some of this stuff, and I said we wouldn't need this. So what if I do this? Yes, perfect, perfect. So we can get rid of these. These are only used for generating opcodes. We now have fewer things that we do. Okay. Now, the only other place that this was used, and this was used, right? I maybe was a little bit brash with how I talked about this. Bin ASM. Okay, this is used in here. So we're going to delete this as an import, and we're just going to take a good long look at what it was used for. Okay, so when we see a line, we get the opcode and then we do the line parsing. Okay, does this look like something we've just done? The answer is yes. The answer is yes. You should be nodding your head right now. This looks a lot like the kind of thing we've just automated in a macro. Okay, so Rust from string. I think we just use, okay, there is a fromster. Rust, do I implement from stir? Do I implement it? Because it said not to implement to stir. Do we want from, like, into? Okay, Rust by example, to and from strings. This is good, this is good. So to. Okay, this is saying from stir. This is saying from stir. So we're gonna implement from stir in here as well. Implement, impulse from stir. Okay, so type so we're gonna move this inside of a macro, and then we can do the same thing. We can just use the value of the opcode directly. We don't need this extra interaction. This is good as well, because this means that in the core library there is a canonical way to go to and from a string. And hopefully that can be round-tripped. Ooh. Now this is interesting, because when we display, okay, let's be smarter with display then, right? Let's be smarter with display. Let's make display look like what an instruction looks like when we parse it. Okay, so this is now round trippable. We can take a program, we can dump the instructions in a format that can then be read back in by the assembler. And this is all just in the core library now. That's cool, right? That's very cool. And this is actually from a string slice, which again is pretty cool. That's not the right word. Self. Okay, from stir. So now we're just going to look at what we were doing here, basically, right? And again, it's going to be the same thing, because we're not going to be able to build these in a generic way, because we need to know what the type of each variant is, like what the types of the fields of the variant. So we're going to do this field from string stir. We're going to be explicit that it's a stir, not a string. And then this will also need a default. Well, actually, let's grab the op as well, because this we're gonna have to break this down into its base parts here, basically, because we're not going to be able to exhaustively match here, because we're matching on like a string, right? You can't exhaustively match a string. So here we're using the numeric value. Actually, what we're going to do is what opcode.fromStir did before. Does this mean... No, okay, it's okay. Don't panic. Don't panic. This is all good. This is all good. But I'm going to steal parts. I'm going to steal the part of this logic where we unwrap a line. Yes, yes, okay, here we go. Okay, so the interesting thing here is this is actually a really interesting, like, this is an important skip, right? This is very important. This is very important. So does our result type need to encode that maybe there's actually just nothing to do? Is this like a ternary thing? Like it's success, it's failure, or it's nothing happened? Skip the line. Ooh. Ah. Because what I'm thinking of is the case where you have a line that's non-empty. Let's go. So say, like, it's easy enough to say, well, okay, the line's empty, skip it. What if we have a line that looks like this, right? Do you skip this? How do you know it's empty? Well, you look if there's any non-white space characters, okay. What if, like, I don't know. This makes a lot of sense right here. in our kind of line loop. But anyway, this is all a bit neither here nor there. It's a little bit pedantic. Right, but we can't just continue here anymore. We need to say, is it an error? No, but it's not a, okay. We need a new error type, basically. We need a new error type. And that new error type, is this like an enum? Right, so there's like no content, or there's fail with stir. Right, does that make sense? Maybe? And now our error type is instruction parse error. No? Maybe? Yeah? Babias says we can exhaust our RAM writing exhaustive matching on a string. Yeah. How many strings are there? Right, in theory, can each string be as long as the longest string our total RAM can hold, right? So if I have 16 gigs of RAM, does that mean there's like that's a big number. That's a really big number. It's like, yeah, it's a big number. It's a big number. Because each of those 16 gigabytes, each of those bytes can have like 255 values, and there's like 16 whatever of them, 16 and a lot of zeros. That's a big number. Okay, so now if the parts length is 0, we're going to get back an error, and that error is going to be self error no content. Return. We're going to return. We'll do a return in there. Cool. So now we can get parts 0. So we match on the thing that is the op. Nice. And we're calling this fields from stir. So we're going to copy and paste this one last time. One last time. There's a lot, like, surely there's something smarter I can do with the copy and paste here, but also, maybe not. Like, maybe I can build all of these at the same time or something, you know, rather than, and in fact, rather than using collect, I should probably just be appending these to, okay, I make a very good point. I make a very compelling point. I can do this refactor off stream though, because I don't think it's necessary. And I don't think it'll actually be fun to watch. I think this journey has been fun to watch. I don't know if everything else will be fun to watch. So we're saying that if, like, we're matching against the string value of the name, and if that's the case, then we want to give back the instruction that's associated with it, right? So if it has nothing, then that's fine. Now, thankfully, we still have this here to copy from, okay? I'm just gonna grab this function as well, because I think that's kind of useful. Again, I don't know what the deal with like polluting namespaces is here, but that's okay, that's okay. Cool, so field from stir. If we have one argument, then we need to assert that the length, again, we're just assuming that this variable exists in the context that we're working in, which is a little bit gross, but that's okay. And then, oh no, again, sorry. Wait, I'm doing this backwards. I'm getting confused about what I'm doing. The fact that this is here is confusing me. Okay, so So we match against the name, we assert that it has the right number of things, and then we parse a number. So can these functions be namespaced inside the trait or something? Like if it's only used inside... So you know, my question is, right, say I have this, I'm implementing fromster, and I have functions that are only used inside this function. Can I add another function here and reference it in self, but only in the context of this? Like it doesn't become part of the impl of instruction? Does that work? Or maybe I just put it, maybe I just put them here. Okay, maybe I just put them here. Maybe I just say like, okay, pub and parse numeric, right? Maybe I just do this. So parse numeric and parse register just become part of this. Well, I mean, for one thing, parse register, are you freaking kidding? This needs to be implemented on register. Excellent. There's another indent. There it is. Cool. Okay, well that's fine, that's fine. And then register needs its own fromster implementation. Okay, we're gonna do that. We're gonna do that right now. Fromster for register is gonna be string. Okay. And we're gonna kind of do the same thing but backwards, right? Does that make sense? Match s. Okay, so we're just gonna record a macro real quick. Let's see if this works. Oops. Nice. I probably could have done another actually no, let's do a macro. Let's do a macro for this as well. Oh wait, no, hold on. Wait, hold on. Okay, so okay, does this work? Oh, it does. Excellent. And now I'm gonna do another. I should have done this all in one go. I should have done this all in one go. It's close. Okay, now, oops. I just overwrote it. That wasn't good. Macro nightmare. Undo. I mean, it actually worked, but not how I wanted it to. Oh, and this needs to be wrapped in a result as well. Okay. And this is going to be our S. Ah, dear. Okay, so, I mean, this is just nicer. This is just better, right? This is the right place for this to live, and it plays in a very rusty way, implementing a very rusty trait. This is what we want to do. Okay, so now we're going to do this again. Whoops. Okay. I think something accidentally nuked my recording then. Okay, good. Cool. Something is still going to blow up here, of course, because I have not finished my job, but that's okay. That's okay. This is good, this is good. I apparently forgot to close a delimiter. This looks pretty closed to me. Oh, okay, no, that's not closed. That's very much not closed. Hold on. Is this just because I've started writing something and not finished it and then forgot what I was doing? Perhaps. Yeah, okay. Wait, what does this line up with? Aha. Yeah. It's because I did this. Okay. Okay, that's good. So the name, so if we have one unsigned 8-bit number, we match against the string of the name, we assert that it's the right length, blah, blah. Okay, this is going to be the same thing, right? This is going to be the same thing, except where we have parse numeric, we're now just going to say register from stir. Excellent. Now, is this a string or is this a stir? Good question. Unclear. I think it's a string. We'll find out. This will yell at me in a second. Now this is going to be the same thing again, except we're going to assert that there's a third argument, a third part, and we're just going to do this. Cool. And that's it. That's perfect. That's everything we need. Of course it doesn't quite work. Expected named lifetime parameter. Ooh. Oh no. Why does it expect a named lifetime? Is this getting into from stir? No, surely not. The fact that it's telling me I need a named lifetime parameter now of all times is just not good. It's not good. From instruction. Filter, this is all okay. Why do we need a named lifetime parameter? Line inner. Oh, right, yeah, of course. S. That makes a lot more sense. From stir. Okay, that's I still don't know where I need this to be because it tells you it goes in a really weird spot because of how how these errors get reported. Couldn't convert the error into an instruction parse error. From string is not implemented. Okay. That's also good. That's also fine. Oh. I just left this dangling. That's so silly. Unknown op. And that's all we're going to say for now. Is it? No. We're going to use a string. We're going to do it properly. We're going to... Well, I mean properly as this nightmare is. Parts 0. Excellent. Again, this is getting better. Parse numeric is not in scope. It's because we need to prefix it with self, because this is no longer just dangling out in space. From string is not implemented for instruction parse error. That's perfect. Map air. No, hold on. Wait. Where does this happen? Where does this get, why does this want to be a string? Does it need to be a string? I don't think it does, right? Struct pass point error. Maybe it does. Maybe this is just a requirement. I have a stir in my error type. It doesn't know how long it references. Oh, perfect. Okay, I've already fixed this. Thank you. That's very useful at M. Somewhere I've got this freaking question mark. Field toString. This is also not like this anymore. I forgot I ditched the comma in favor of just simplicity. Register from stir. Oh, right. Yeah, because we're inside a function that. Yes. Okay. So what I want to say is map x like that. This is so hectic to read. Like, it is just such a freaking long line. I can't tell what's going on. Okay, this, perfect. From stir, now here we're also going to say map. We're going to make sure there's only one dot, because that went wrong last time. Now we're going to have to do this twice, but that's okay. And we're going to put these two on their own separate lines, because that's going to look better. Map x self fail x. How do these error types look? Like, what are you actually supposed to do in Rust? This is what I don't fully understand. I should probably take the time to like learn it, but also I'm just kind of messing around and it's working. Why are these different lengths? Because I lost a semicolon. Okay. Oops. Okay. Now we're back to these errors. A result may be an error variant which should be handled. This result may be an error variant which should be handled. Ooh, something is a result and it's not being unpacked. We're ignoring something that can fail. That would be this, right? Okay, so here's another thing. If this is an enum, can I still like, what's the word for, like, kind of, you know, do it point free, I guess. Is that allowed? Is that illegal? We'll find out. Well, we won't find out because I'm not even going to try because I'm too much of a wuss. I'm afraid. I'm afraid of the truth. Okay, good. Bin ASM. From stir is now gone. Wait, no, hold on. Yeah, from stir, it's gone apparently, somehow. Not found in the scope. From stir. Weird. It says it's oh, hold on, it's unused somewhere else. It's unused here. That makes sense. Now handle line is dead. It's gone. It's done. We don't do that anymore. All of these, they're gone. This assembler got so much simpler. These core types now carry so much more baggage, but that's good because that means that everything can use it in a very unified way. I think that's good. We still skip comments here, but now we just have this whole line inner, and we're just gonna say instruction from stir. From stir map Now, how do we deal with, okay, so let's do this, match. Actually, there's not much happening after it. Let's just go match. If we match this, if we get an okay instruction, then we do everything that was out here before. If we get now if we get an error which has an what did I call it? Instruction pause error. So this needs to just live outside of this macro, because it's like, this is something we need to be able to refer to. We don't want to have to dig into a macro every time we want to see what these variants are. Variant, not discriminant. Okay. Okay, good. What do I call this? Instruction pause error. If it's a fail, I hope I can do nested matching like that. That should be fine, right? Rust can work this out. Rust's pretty smart. Panic, and then everything else we're just gonna say continue. Okay, this is looking better. Okay, instruction pause error. That's because we can grab this. This means we no longer depend on register in our assembler, which is very interesting. That's kind of cool. Instruction variant or associated not found. From stir, not found an instruction in the current scope. That's because we have to use this thing that we literally just deleted, which is hilarious. Expected stir found string. It's because we can borrow. We can borrow here and Rust will work it out. Okay, so cargo run assemble cargo run VM. Perfect. And there we have it. A full virtual machine that is running. Amazing. And so just to be completely clear, right? If we look at ops, this is all we define now. This is all we do, right? We just define what we want. And I can add another opcode, and let's commit first, okay? Let's try and get some hygiene in here. Let's try and get some git hygiene. What have I got? Remove opcode type. Macro magic does everything. Excellent. So let's add a new opcode. Okay, ready? Opcode hex 22. This is gonna be sub stack, and then let's add another one as well. Let's make it opcode 23. We'll make it sub register, which is gonna take 2 registers as arguments, just like addition does. And let's see what happens when we cargo build. Now this will fail, okay? But it's gonna fail and tell us exactly what we've failed to implement. If you remember back a few streams ago when I did this, it gave us like 58 places, right? Because I needed to manually do the string mapping into the instruction and the instruction mapping into the opcode, and I needed to make sure those mappings were correct. And when I got it wrong, it really blew up. Now there is one place that I have missed this, apparently. Maybe it's going to find another one for me, but in our main virtual machine loop, or in our main virtual machine step function, we just need to handle the instruction. So let's do this. Instruction sub stack. This is just going to look a lot like, let's continue to copy, in fact. Let's continue to copy. Clean up this stray curly brace. And now it's kind of like we can't even forget, right? If we copy add stack, if we have it twice here, I think Rust will complain at us because we're using it twice in a match statement. If we forget an instruction, Rust complains at us because we're forgetting it inside of a match expression. So the match expression does a lot of heavy lifting here. It's pretty cool. It's pretty cool. Bobius says they want to consider writing a macro for the same stuff. I think you should. I think you should. This is a good way to work. Okay, cargo build. That's it. That's all we had to do. These lines, that's it. All the encoding, all the decoding, it's just taken care of for us. So let's go into our test program. Let's add stack. So instead of this, now let's sub stack. Let's just change it, right? We'll run our assembler on our test program, VM, and that looks possibly correct, right? Because we were doubling the number before, now we're subtracting it from itself, which should give us 0. Let's try something else. Let's say we had 21 before. Okay. We need to do that backwards. So we can still like panic and blow the machine up, which isn't great. So we had 21 in our A register, then we subtract 1 from it, and now we have 20 in our A register. That's pretty cool. That's a new instruction for basically no work. So now that I've done all of this heavy lifting up front with these macros, now we can just fly home, right? There's no work, none of the manual work. Instruction encoding, instruction decoding, it just happens because we were kind of smart about how we define this. So this is really cool. I'm really, really glad that I've invested a little bit of time into Rust macros, and honestly, like, you know, probably like more than half of the total runtime of writing this machine now is just working on this monster macro, but it's so cool. It's so cool. Bobius is thinking of having a bunch of different addressing modes for instructions such that you might write one opcode, depending on the operands, it'll have different machine code instructions. That is like a higher level thing, right? You could still do this, but then you have a higher level assembler that kind of does some of that magic as well, right? But I think there is really some value in having this round trippable thing. You can take a binary, you can dump it into a format that is readable by a human, like what the actual instructions that the machine runs are, and then you can always round trip that back into a binary. That's pretty useful. So even if you do end up writing a higher level assembler, like when you look at how complicated my assembler is now, it doesn't really do anything. It doesn't really do anything. All it does is read the lines and pipe it through the machinery that we've already provided in the core library. So it, you know, I very much could write another assembler that does that kind of thing, that knows how to encode higher level, you know, an instruction is actually maybe 2 or 3 instructions, but it hides some of the complexity underlying the machine from the user. Okay, I'm going to do one more thing here. Real quick, I'm at least going to start looking at this. Okay, I'm going to start looking at it because I really want to. Where are we? Okay, because I have a pull request, okay, from a viewer. Ben has been tuning in, has been chatting in the Discord a little. Shout outs to Ben. Ben has made a PR. Ben apparently is quite young as well. I can't remember. I think I can't remember how old Ben said they were. I think they were pretty young. They have done some of this linter and formatting stuff that I've been meaning to get to, but I haven't got to yet. So we can say, let's just commit add substack and subregister instructions. Subregister sounds like a very sinister word. Okay, so we can say cargo FMT. cargo FMT. And now if we git diff, we can see that cargo FMT has gone through and has done a bunch of really nice formatting for us. It's put spaces around things. It's gotten rid of unnecessary commas. It has reordered our imports to some canonical ordering. I don't know what has changed on this line, but something has changed. This is the same line. Look at this. It's nicely spaced things out for us. Yeah, reordering things. Nice. This is good. These are good changes. These are just good changes. Yeah, like this is lovely. This is lovely. Fixing my shoddy indentation. Look at this. Alphabetizing my imports. Wow, yeah, it decides where your spaces should go, which is kind of cool. Again, I don't see what the difference with this line is, but that's okay. Puts this bracket on a new line, apparently. Sure. Cool, so this is kind of cool. So I could, I kind of want to rebase. I kind of want to rebase this, so that I can merge this PR specifically. And yeah, mnemonic is the word I mean. You could round trip it, right? But you would need extra context. Yeah, yeah, basically. I think round tripping a higher level thing is just like a different problem, and it requires a different chunk of work, because this, like, it's taken time to get here with the macros, but because it's so automatic, I'm like, well, just copy what I've done, and then you get this like fundamental round trip, and it directly represents what's in the binary as well. It's kind of useful for debugging anything else in a sense, right? You can always have this lowest level thing that you can put into a human readable format and back. But it's not required, and you're absolutely right. You can round trip, pretty much anything, like as long as you're not losing information. Things like labels and whatever that get lost in compilation, right? There is some fundamental round trip that you can do of your data. Okay, so unsafe code is forbidden. Interesting. I don't know what the standards are here. As far as okay, they actually haven't. So because this is basically just running, if not entirely just running cargo format, I think I might just like credit this PR and close it, because otherwise I would have to basically rebase it. Yeah. Oh no, code more idiomatic. Okay, there is actually a bit of work here. Okay, actually, I'm not going to decide on this right now, because I would like to merge this very helpful person's PR, but because I've made changes, I'm going to have to do a rebase or something. But I can do that. And again, I might do this off camera. So I'll push these changes up. I'll tag them up nicely. You can have a look at my macro magic, and please critique me. If it's bad, tell me I need to do better. Show me what I need to do better. Make a PR and show me. That's really cool. I love that. I think that's a great way of interacting. And then we can have chats in the comments and stuff, and other people can chime in. Also, I think Ben has been making, I'm not sure if it's like a fork or what, but they have a competing virtual machine. I was having a bit of a look. It looks very similar to what I have here. Actually, hold on. Do I have labels? Did I call, is this my readme? No. Okay, yeah. So they've stretched out my readme. They've reserved a symbol that I have not reserved. Yeah, they're building their own virtual machine. Apparently inspired, kind of following along. Nice, lovely. That's numeric. Yeah. So I'm seeing a lot of like similarities, but taking their own direction with it and doing their own stuff. So this is really cool. I love to see it. Giving it a cool name, giving it a cool little logo, very Celeste. So yeah, shout outs to Ben. Love to see it. If you're making your own virtual machine, Bobius, please link your stuff, shout it out. Adam Shackart says, is this an exercise for learning Rust? Am I finding the language worthwhile so far? I am really enjoying Rust. I'm loving the compiler. I'm loving how explicit all of the errors I get are. Like, I'm able to write some code, chuck it at the compiler, and the compiler says, no, fix this, then it'll work. That's really cool. That's really, really cool. But yeah, I've never written much Rust before. I have written a little bit. I did a bit of code archaeology today, actually. I went and I dug up the sources to some old, 2015, 2016 C projects that I did while I was at uni. And then now you can download the sources on my website and look at how hilariously bad my code was at the time. But I did write a bit of Rust in 2014, apparently. And I actually wrote a simple little virtual machine, but a much more primitive one. And it was much worse code, and I had no idea what the hell I was doing. But I have written Rust before a very, very long time ago, just a little bit, back when I couldn't really write code like I can today. I wouldn't have been able to do any of this macro stuff and just work it out. But yeah, I've been playing with macros today, and for the last few days, macros are really cool. It's been extremely rewarding. Laund, welcome. I am just finishing up, unfortunately. A couple of people coming in here right at the end, but make sure you go back and have a look if you like Rust, if you like coding, and also if you check out my website, I have just put a section up about tutoring. I'm gonna take some students. If you want to pay me money to learn coding from me, I am not cheap, but if that interests you, have a look. It just helps support me and me keep staying independent and just working on my own stuff. So that has been a very fun stream. It's good to have this macro stuff behind me. Next time, we're going to implement more instructions, more functionality. We're going to make the machine actually do things. We're hopefully going to write some unit tests, going to work out what we're doing. Laund, here's a good question, right? You come over from a Rust Twitch stream. Do you care much about Twitch versus YouTube streams? Because I definitely get fewer viewers on YouTube, but I also don't really care too much about live viewers. I would rather build stronger followings in my VODs. I think that's more rewarding, but also maybe not. Do you reckon I should go to Twitch? Because I have a Twitch channel. I've got followers on it. Like, should I just go back or should I just commit? YouTube is just harder to find stuff. I have found that as well. So probably like Twitch stream with a strong YouTube VOD upload regimen. I can probably do that. But yeah, it's not much of a thing to me. I've been experimenting with YouTube streams. I've done Twitch streams on and off since, I don't know, 2019, I guess, 2018, really 2014. But those were dark days of very low bandwidth uploads. Have to add the live filter to find anything interesting. Okay, well, I'll think about this. But yeah, like now that I've kind of hit, I'll probably do a few more streams of this project on YouTube, but then the next project I might swap back to Twitch. Yeah. Well, Bobbius, I've already got you in. You're already in my Discord, right? I don't have to worry about you. You're here. I think there is more of a scene on Discord, and yeah, and if I'm going to start doing this more and like taking donations properly and stuff, probably Twitch is the place to do it. But anyway, all things for me to think about. Thank you very much for your input. Let me link my Discord, by the way. If you like Rust, if you like hanging out, we've got a couple of keen little Rust programmers. So let me just... Ooh, this is an interesting comment. Someone should make a meta stream search across all platforms. Maybe that's a fun project for another day. I'll keep that in mind. Thank you very much for the suggestion. I'll put that on my list. So thank you all for stopping by. Just link my Discord in the chat. You dream of hiring me someday. What are you paying? What's your hourly rate? I'm talking to someone at the moment in America about maybe picking up a little contract, but I'm not rushing back to full-time work. I'm just hanging out and doing my own thing and trying to make money here and there while I can. But yeah, we'll get there. We'll get there. Any little fun ways I can make money doing my own thing programming is cool. Anyway, that's enough chat. I have to get to bed because it is well after midnight. This has been a fun stream, and I will catch you all again soon.